we have made it to the last video in topic 2, which I feel has been the longest chapter that I have ever seen. But finally, we have done our intercepts, we have done our slope. This is just one last thing, kind of tying in our equations into some real life scenarios here. Okay. So our first example shows how far a car travels based on the gallons of gasoline used. Okay, so if we're looking at this, our X, okay, that would be like our input. Okay, so X is our inputs. Okay, we're plugging in the gallons of gas, and you would get out our output. Our Y is the distance in miles that this car has traveled. So it says write an equation for the graph. So we know it's going to be in y equals mx plus b form, but we need the m and we need the b. So we're going to look to our graph for that. Okay, well, our b is 0. It goes through the origin. Okay, it's a proportional relationship. So we actually don't have to put a b in this case. We just need to figure out what the m is. Okay, and there's a couple different ways to do that. If you're realizing it's a proportional relationship, we can just, find an ordered pair, do the constant and proportionality. Okay, we can choose 2 points, okay, and figure out our rise over our run. I'm going to do that. So I'm going to use our origin because that's a nice pair, ordered pair there. And I'll use this point right here. Remember, we're looking to see where it crisscrosses on the grid in a nice spot. There's actually lots of points we can choose from. Okay, but our rise over our run, it goes from 0 to 20. So our rise is 20. Our run, so we're looking at the x values now, goes from 0 to 1. Okay, so our run is 1, which means our slope is just 20. So based on that information, okay, y equals mx plus b, by equals 20x. And we said the b was 0, so we do not need to put the plus 0, and that is our equation. Now, what is this graph telling us? Well, there's only one number here that we need to deal with. Okay, this 20. Remember, we're plugging in the gallons of gasoline. That's our X. And it's giving us the distance the car travels. Well, this is really telling us for every gallon of gasoline, okay, every gallon of gas, the car travels 20 miles. Yes, so 20 miles. Okay, because for the first one, it travels 20. The second one, it also travels 20, but that puts it at 40. So this is just saying every gallon of gas, the car is traveling 20 miles. Okay, it's a unit rate in this case. Proportional relationships. Okay, that slope is the unit rate. I'm going to just say 4 proportional relationships, just so that we're clear. It's not always a unit rate, but proportional relationships it is. Okay. Example 2, Mary is going bowling. The bowling alley charges a certain amount per game, as well as a fee for renting shoes. And the graph shows this information. Okay. Okay, so we are going to look at this and write an equation for the graph. I feel like those points are not quite on the points though, so that is slightly worrying me. Oh, so I feel like they're throwing us off here. Like this point and this point, I can't exactly tell what they are. But if I look at this, I feel like this point and this point are pretty good there. Okay, I crossed at a nice spot there. So I'm going to use those points. Okay. So we're going here. So from, this is 6 because it's going up by 2s. So 6 to 12 means our rise was 6. And our run, it went from 2 to 6, which means our run was 4. So our slope is 6 over 4. Now, normally I say we would simplify that to 3 over 2. But in a real world problem, okay, we probably do want to write that because this is referring to some money. Okay, we're bowling a certain number of games and it's charging us a certain amount of money. Okay, so if it's just a graph of a line with nothing to go with it, leaving it as 3/2 is the best way to do it. Okay, but here, since it's representing something, let's say that 3/2 is really $1.50. Okay, so that's our M. So we know it's going to be Y equals 1.5. I guess we can just say 1.5 because it's money. I'll say 1.50x. Okay, $1.50 per game. And I'm thinking it's telling us, I feel like it's halfway between the 2 and the 4. So I'm thinking we're supposed to say that the y-intercept is 3 here. Okay, and that is our equation. Slope was 3/2 or 1.5. The y-intercept was 3. So y equals 1.50x plus 3 because we're plugging in the number of games. Okay, and then that's our value. So what is this telling us? Well, we wrote this equation. Okay, and it's telling us a couple things. Okay, this $3, that's just, it's a flat fee. Okay, you might hear people say that flat fee, initial fee. Okay, in the context of this scenario, that's going to be the cost of the shoes. So the cost of the shoe rental is going to be $3 because that doesn't depend on how many games you play. You can pay the $3 for the shoes and only bowl 1 game. You can pay $3 for the shoes and bowl 10 games. But no matter how many games you play, your shoe rental is still going to be $3. Okay. The other aspect of that is that $1.50. That's being multiplied by your X, which is our number of games. So that is telling us that you're being charged $1.50 per game of bowling. Okay. Example 3. The flyer shows DJ Dave's rates. Write an equation that tells how much it will cost to hire Dave, Y, based on how many hours Dave DJs for, which is X. So Y is the total cost and X is the number of hours. Okay, in this case, we don't have a graph, so we need to pull out this information from this flyer. We know it's going to be Y equals, okay, if X is the number of hours, it makes sense to take his hourly rate and multiply it by X. So that is our slope. Okay, so 75x. And the setup fee, that's that flat fee, that initial fee. It doesn't depend on how many hours he's there for. It's always going to be $125. That's our y-intercept. So our equation is y equals 75x plus 125. Okay, so I'm just gonna, I have a little bit of space here, so I'm just gonna do a little summary real quick. So our B, our y-intercept, okay, some things we've called that flat fee, initial amount. We can say starting value. Okay, depends on the scenario, kind of which one makes the most sense there. Okay, but it's a constant. It doesn't depend on what our X is. Okay, our M, okay, we've been calling it slope. Okay, I do want to throw in the words rate of change because you will see that as well. Okay, just how is the equation changing? Okay, how quickly or slowly is it changing? That's the rate of change. Okay, and that goes in front of your X. Okay, last one. We have Sasha's hiring someone to clean her house. The cleaner charges $15 for supplies and $60 for each hour spent cleaning. Write an equation that gives the cost Y the cleaner will charge Sasha based on the number of hours she cleans, which we're calling X. So Y equals, all right. We have 60 for each hour, and the number of hours is X. So it's gonna be 60X. And then $15 for supplies. Okay, doesn't matter how long she's there for. That's our y-intercept. So plus 15.